Sharma, or sorry, it just started recording. Okay, so with that, let's please welcome Ashish Sharma, who is a current PhD student at the Paul G. Allen School of Computer Science and Engineering at the University of Washington. His research focuses on building computational techniques for encouraging empathic conversations in text-based mental health support. Take it away, Ashish.
Yeah, thanks, Naomi, for the introduction, and let me share my screen. Okay, can you all see it now?
That's good.
Oh, thanks. All right, thanks, Naomi, again for the introduction. I am super excited to present our work on facilitating empathic conversations in online mental health support. And I will also talk about how we used cloud, in particular Microsoft Azure, throughout this project and making this project more effective and efficient. So this work was done with our clinical psychology collaborators from Stanford and University of Washington, Adam Miner and Dave Atkins, also with my advisor, Tim Eltoff, and Ela Nin, who did this work with us as an intern. Content warning before we start. So this presentation may contain examples related to suicidal ideation and self-harm. We use those examples to only illustrate our points better, and we have ensured that all the examples are properly anonymized. All right. So mental illness is a global health issue, but still mental health care remains a global challenge. So most countries have less than one psychiatrist per 100K individuals. And across the globe, we face widespread shortages of workforce for mental health support with limited in-treatment options. So facing this huge gap between need and access to mental health support, many people are instead turning to these online mental health support platforms. So platforms like TalkLife, 7 Cups, and even mental health subreddits on Reddit. These platforms enable millions of users to seek and provide support, and that happens through conversations. So the conversations are typically text-based and asynchronous. So a user who wants to seek support, whom we call seeker, will post about their mental health related issue and will get responses from peer supporters on the platform. Now, a key component for providing effective and successful mental health support is empathy, which is the ability to understand or feel the emotions and experiences of others. So consider an example where the seeker posted, "My whole family hates me." Now, one way of responding empathically to this post would be to understand that if the family of the seeker hates him, it could make them feel isolated. So an empathic peer supporter would say, if that happened to me, I would feel really isolated. Now, this has a very strong effect in mental health. In fact, studies have shown that empathic interactions have strong associations with positive counseling outcomes like alliance and rapport. But empathy is highly nuanced, and expressing empathy requires expertise and training. However, peer supporters on these online platforms are typically untrained, and they are unaware of empathy and other best practices in counseling. And this gets reflected in their conversations, as we find that highly empathic conversations are rare on these online mental health platforms. Instead, these peer supporters often resort to strategies such as suggesting actions like try talking to your friends, but that is not an effective way of providing support. So the key question that we wanted to address in this work was, how can we improve empathy in peer-to-peer support? So how can we turn these low empathy conversations on the left into the higher empathy conversations on the right? And our hypothesis is that peer supporters may express higher empathy if they received AI-based feedback. And we want to build computational methods which can facilitate and generate such feedback. And towards this goal, in this project, we introduce a new computational task, which we call empathic rewriting. So in empathic rewriting, the aim is to computationally transform low empathy conversations into higher empathy. So for example, given a post from a support seeker, I can't deal with this part of my bipolar, I need help, and a corresponding low empathy response. So don't worry, try to relax, anyone you can talk to. We want to increase empathy in the response by transforming it to something like, being manic is no fun. It's scary. I'm sorry to hear this is troubling you. Try to relax, anyone you can talk to. Now, note that the rewritten response should communicate more empathy, and that typically happens through understanding of feelings and experiences. So, understanding that if the person is facing bipolar issues, that might involve manic phases and it can be scary. And also through displaying the felt emotions. So, saying things like, I'm sorry to hear this is troubling you. But empathic rewriting is a really challenging task due to several reasons. And the few of the computational ones is what I will highlight in this particular slide. So for instance, one can try and take a naive approach of transforming every response to a generic empathic response. So for example, you will rewrite every response to something like, this must have been really hard for you. Now, while this may seem to quote unquote solve empathic rewriting, but it suffers from two key issues. First, it may not be specific to the emotions and experiences that the seeker is expressing. And second, if you perform the same transformation to millions of responses on the platform, that will dramatically reduce response diversity. So as in every response on the platform would become, this must have been really hard for you. And prior work has shown that people seeking support hate these kind of generic responses. So therefore, we need to develop and train new computational models, new NLP models that can learn how to make these kind of empathic changes to text. Now, the recent advancement and breakthrough in NLP has been driven by these massive language models, which often have billions of parameters. So for instance, the recent OpenAI GPT-3 model had 175 billion parameters. And therefore, to train these models, we need GPUs and we need TPUs and we need lots of them. Another challenge involved here is related to deploying these models in the real world, which in our case involves giving people real-time feedback on how they can improve their conversations and how they can make their conversations more empathic. And this requires platforms which can serve these models efficiently and reliably to a large number of users all at the same time. All right, so our key insight working on this project has been that cloud can help, and it can help us meet our computational needs. So using cloud, we can train and deploy these large language models, which have these like massive number of parameters in a flexible, feasible, and reliable way. So throughout this project, we use services provided by Microsoft Azure. So we use Azure for creating several machines of different configurations, example with different types of GPUs or with different numbers of GPUs, which all serve different purposes and different needs that we have for this project at different stages. And that's what I will try to cover in the rest of the presentation. So first, let's discuss the model that we built, which will help us understand the different needs that we had and how those we were able to map to Azure in particular. So the model that we built is called Partner, which is a reinforcement learning model for empathic rewriting. So we use the standard reinforcement learning setting. I will go over it at a very high level. So the standard reinforcement learning setting with state, actions, policies, and rewards. So in our setting, partner will work on a conversation between a seeker and a peer supporter. It will extract a state from the conversation. And based on the state, it performs a set of rewriting actions uh, using a policy and finally gets some rewards that it uses for training. So states, actions, policies, and rewards is what I will cover in the next few slides. So we use seeker post and fixed length contiguous spans of response post as our state. Actions. So our model takes sentence level edits as actions. So it will either insert empathic sentences at different positions, or it will replace existing low empathy sentences with sentences that are more empathic. So at each step, it will take two actions. So the first action would be for selecting a position in the response span, which can be used for insertion or replacement. And the second action would be to generate candidate empathic sentences that can be used at those positions. So in the example on this slide, So through action one, which is about selecting a position, the agent can select the first sentence for replacement. And through action two, it can generate a candidate sentence like being manic is no fun, which can be used for replacing the first sentence. And finally, you have your read run potentially more empathic response. So this slide illustrates our policy network, which uses a transformer language model based on GPT-2. So transformer, just again at a high level, is this large language model, which is based on this concept of self-retention. So like figuring out in a particular sentence, let's say, like how a particular word might be related to other words, and using that to perform different tasks, such as maybe like predicting these positions or generating different sentences that we want to generate. So this policy network takes a seeker post and the contiguous chunk of the response post as input, which were our state. So it passes them through a transformer language model, which was based on GPT-2. And it performs the two actions I was talking about. So identifying positions to make changes and generating candidate sentences, which can make those changes. And by applying those actions, you get your final rewritten, more empathic response. So this reinforcement learning model was trained using a series of rewards, which ensure highly empathic rewritings while maintaining language properties and conversational properties like fluency, specificity, and diversity. So first we have change in empathy, which is computed as the empathy of the rewritten response minus empathy of the original response. And this was obtained using a classifier which was developed in prior work, which has a scale from 0 to 6. We also have text fluency and sentence coherency, which are used to ensure grammatically correct English sentences. And finally, we have mutual information, which is used for ensuring specificity and diversity. And our total reward is a weighted sum of these individual reward values. All right, so back to cloud and back to Azure. So the different components that we saw in this model that we built, and also the different stages that we have for training. So all of them have different GPU needs and different GPU requirements. And I would like to highlight a few of them here. So for instance, a couple of our pre-processing and warm start stages required like smaller capacity GPUs, whereas the main components of our model, so things like the transformer language model, they required much stronger GPUs. So in one of our pre-processing steps, we find that like TalkLife, the platform that we were working with, so it hosts a large number of social media interactions along with the mental health related interactions that we, I think, wanted to focus more on. So what we do is we curate only mental health related conversations. And for this, we use like a BERT-based classifier, which is again the standard transformer language model, which is commonly used in Azure language processing. We also perform a warm start supervised training of our reinforcement learning model. So what we do is we create a data set with empathy measurements, for which we used a classifier developed in prior work, which is then used for the supervised warm start. Now, the first pre-processing step, which was about curating mental health related conversation. So the classifier which we use for that, it only requires a GPU with like 8 gigs of RAM, whereas the warm start stage, which was the second pre-processing step, so that requires a GPU with around 12 gigs of RAM, 12 gigs of memory. So, I mean, since you have these waiting needs, what one can do is like one might be fine using like a lower memory GPU for the first task. So maybe just using like an NVIDIA RTX 2070, whereas for the second task, you might need to use like a higher end 2080. And similarly for the policy network that we saw, so like as a whole, that requires 16 gigs of GPU, and for which you need something like a NVIDIA P100. But then we also have this reward function, and this reward function has like lower memory requirements, which will only need like a smaller GPU. Now, we use Azure for training our models, so which gives us immense flexibility on which GPU to use at different stages of our training. So with Azure, what one can do is one can create these different machines with different types of GPUs and use them according to their needs. So for instance, maybe for our pre-processing stage, we only need like a smaller memory GPU. So one can create that kind of a GPU because you only need that, and it would be a much more cost-effective process. Because of course, I mean, if you are using like a smaller capacity GPU, that will cost you this. And then maybe, for instance, when you need like a larger GPU, then you can create that kind of a GPU, and then I mean you can uh, do all the different stages that you have in your model in a much more flexible way. And of course, we have been talking about memory and the amount of memory that each GPU might have, but then that is only one aspect of the model training. So there might be other requirements like time it might take to train the models on a GPU, which might be of more importance, and one can make decisions on which GPU to use accordingly. Another task where cloud is immensely helpful is for scaling these models. So an interesting use case which requires this scaling is the task of hyperparameter tuning. So in hyperparameter tuning, the aim is to find the optimal set of hyperparameters for your model. So for instance, if you have like a deep learning model or even like a machine learning model, so maybe you want to find like the optimal number of layers that you want to use in that model. Now, in our context, one of the important set of hyperparameters that we saw earlier were related to this total reward value that we computed. So we have these individual reward values and we combine them using different weights to get our total reward. And finding the right set of weights for combining these reward values, that is very important because that will determine the performance of your models. So the question then is, what are the values of these weights for which you will achieve optimal performance? And as many of you might know, the way this is typically done is using an exhaustive grid search, where what you do is you'll check for possible combination of values and you will find the optimal combination. But the problem is that it scales exponentially with the number of hyperparameters that you want to tune and also the number of possible values that you have. So for instance, let's say if you are checking like 4 values for each of these 4 hyperparameters that I just highlighted, so then you will need to like ideally train your model 4 to the power 4 times or 256 times. So as you can see, it quickly scales up with these hyperparameters, and you will need like a large number of GPUs for scaling this type of hyperparameter tuning. And that's where, again, cloud can help, and the way in which we were using Microsoft Azure can help. So on Azure, what you can do is you can create machines which have different number of GPUs, or in fact, you can create many parallel machines which make hyperparameter tuning and other similar tasks which require similar level of scalability much more feasible. So now, for instance, you do not need to like sequentially train those 256 different models that I talked about. Rather, what you can do is maybe you can create these parallel machines, and then you can train all of those in parallel and get the results from those, and finally choose your optimal set of hyperparameters. So as we saw, cloud has been like really helpful in training our models and making those models much more flexible and scalable. But then what do the results look like? So we perform different evaluation. So we perform like automatic evaluation where we use a bunch of like automatic metrics which do not require like any human intervention. On the other hand, we also do some human evaluation where we ask humans to rate the rewritings that we were generating. So, so for automatic evaluation, the matrix that we used were as follows. So change in empathy, we had perplexity, then we also had sentence coherency, specificity, diversity, and edit rate. So all of these metrics, they try to assess different like language properties and conversational properties that might be relevant for empathic rewriting. And we compare this model against different baseline models from related tasks like dialogue generation and sequence to sequence generation. So things like machine translation. And all of these models that were like state of the art for these related tasks. So this table shows results on our change in empathy metric. And we find that our model, which was partner, is able to increase empathy by over 1.6 points on a 6-point empathy scale, which is 35% more than all the baseline models that we compared against. So we find that partner outperforms baselines in empathy improvement, and it generates fluent, specific, and diverse outputs with lower number of edits. Now, we also do human evaluations. So these automatic metrics can often be very, very noisy in these type of settings. So for human evaluation, what we do is we recruit 6 graduate students who had significant expertise in clinical psychology. Most of them were in their second or subsequent years of their degree program. And according to our clinical psychology collaborators, they had significant expertise in empathy and mental health support. So for this human evaluation, we do A/B testing. We show our participants an output from our model and a corresponding output from baseline, and ask them to choose the output which is more empathic, fluent, and specific. So this plot shows our human evaluation results for empathy and specificity. So on the y-axis, you see different baselines, and on the x-axis, you see preference scores. So here, the values which are greater than 50%, they indicate preference towards our model. They indicate preference towards partner. So we find that humans prefer partner over baselines in terms of both empathy and specificity. So here I want to show you an example demonstrating our system. So to a seeker post, I feel like nobody cares about my existence, and an original response, I feel the same. So a baseline model like DialogGPT can only rewrite it to something like I care, but then our model, which is partner, can rewrite it to it's hard to find others who can relate. I feel the same. So which is like much more empathic and potentially more helpful. All right. So now we have a model which can effectively perform empathic rewriting. And then we used cloud and Azure for training it and for doing it in the right way. So getting the right kind of models for the different stages of training. So then the next question that we had was, can we leverage this model to intervene on conversations through real-time feedback? So to answer this question, we are conducting a randomized controlled trial to study whether intervention using the feedback that we generate from the model that we build is helpful in improving empathy. So in this study, what we do is we recruit users from the TalkLife platform, and we randomly divide those users into control and treatment groups. So the treatment group participants receive feedback while they write their responses. They receive feedback from the model that we built on how they can make their responses more empathic. And the control group responses write their responses without any feedback. So this is what the feedback agent that we built look like, which will give feedback to users in real time and will actually intervene on empathy and how conversations can be more empathic. So we show users a seeker post and ask them to write a supportive empathic response. Along with this, we also show them feedback prompts, which the users can use whenever they want any help with their response. So in this particular example, the seeker post was, I am feeling lonely. So let's say I want to write the supportive empathic response, and I start my response by writing, I am here for you. But then I am not particularly good at providing support, and I don't quite feel confident with my response. And that's where this feedback agent can be helpful. So the feedback agent will take the current response and the seeker post as input. It will assess how empathic the current response is and what are the kind of changes that can be made to the response so that it will be more empathic. And then it will return back a bunch of suggestions. So suggestions on the kind of changes that can be made. So for instance, the sentences that can be inserted at different positions, and sentences which can be replaced with other sentences which might be more empathic. So so this is how these suggestions are shown, and one can click on these like insert and replace kind of buttons, which will change their response to something that will be more empathic. And finally, you have like a more empathic response. All right. So for this feedback mechanism and for this feedback agent, so we need something which can using which user can request the model that we build. The user can request partner and get suggestions for rewriting, as we saw in the last slide. And this is again where cloud can help, and this is again where Azure can help. So what we do is we serve a partner through Microsoft Azure, and we use that again to serve these requests. So whenever a request comes, it goes to the Azure virtual machine where the machine is serving the model, and then it will like do the computation. It will assess how empathic it is. It will try to generate these changes, and it will return those changes to the user, which will be displayed on the interface. All right, so to summarize, empathic conversations are crucial for effective mental health support, but empathy is rarely expressed online. So the question then was, how can we facilitate empathic conversations? And to answer this question, we introduced this new task of empathic rewriting for computationally transforming low empathy conversations to higher empathy. For this task, we developed a model called Partner, which was this reinforcement learning agent for empathic rewriting. We showed that it can effectively perform the task of empathic rewriting. For this task, we used cloud. We used Microsoft Azure for training it in a flexible way, in a feasible way, and in an efficient way. And finally, we showed that this task can be used for giving feedback to users, feedback which will be intelligent and feedback which will be actionable. And again, we used cloud and Microsoft Azure for giving this feedback and for creating the system that we built and for deploying it in real world. So that's pretty much it. Thanks a lot for listening, and I will be happy to take questions.
Thank you, Ashish. We have just a comment in the chat from Ed. This sort of work is really important and a great example of how computing and computer science can assist in addressing important social challenges. We've had some questions collecting in the background. One is just a logistical question. Is it correct that each partner transaction is independent of conversation history?
Okay, so it will depend on the conversation history. So like when you perform the task of empathic rewriting, you do need some context, as in like what has the conversation been about so far, and like how can you use that to generate the right kind of empathic responses and the right kind of rewriting. So it does use some context from the conversation, and I mean, in fact, that context helps in generating the right kind of empathic responses.
Cool. So then I guess in that respect, we had another question. Do you see opportunities to expand beyond message level analysis and rewriting? And how practical of a task do you think that would be using cloud resources? So is that already actually occurring to some degree?
I think that's a great question. So, I mean, the question is about like, can you go beyond maybe like message level rewriting, and can you maybe like rewrite conversations as a whole? So maybe you take, I don't know, like a snapshot of a conversation, and then you suggest changes at different points in the conversations. So currently we were limiting ourselves to a particular conversation, a particular utterance or a particular message. But then I can see opportunities on how we can extend ourselves and generalize ourselves to like conversations as a whole, and making changes at the conversation level. I think when we do that, I think one of the challenges would be to, I mean, scale our resources and to probably, I don't know, like use maybe like even bigger models and bigger GPUs. Like, of course, like as your context grows and as your space on which you need to act grows, you need, I mean, you will like inherently need models which will be much larger. And I think which is where again cloud can help and Azure can help. So I think like just the ability to create like all these different GPUs, like all these massive GPUs, and use that to train your models. I think that's where I think cloud can again.
Exciting. We have a question talking about those very powerful GPUs. When you showed that table of different instances with different GPU sizes that cost varying amounts, we have a question asking, are there automated ways of shutting down these VM instances when the training is done so that those like super beefy GPUs don't continue incurring costs? Or I guess just more generally ways of managing this corral of compute resources that you've collected?
Yeah, thank you for the question. The answer is yes. It is possible to shut down these virtual machines when you are done with your training and when you don't really have any task running on these machines. So it is possible to do that. And if you do that, it will, I mean, like almost cut down your cost per hour to like zero. It won't be exactly zero. So like since you will be storing some of your models and some of your codes on that virtual machines, since this space which has been allocated for that virtual machine would still be active and would still be in use, which is why you will incur some cost, but that cost would be almost negligible compared to like what the cost is for like actually doing computations on the VM. So yeah, I mean, you can, I think, shut down your VMs. I think talking about the other part of the question, which was about like what are the other kind of things you can do. So I think, like, of course, I mean, like you create these VMs. I mean, you can create them in like different configurations. Now, once you have them up and running, I think like other things which are interesting and like especially which are I think like specific to Azure. So things like, for instance, you can access your servers through like different types of interfaces and through different places. So for instance, being able to access it through maybe like a terminal on your local machine, or even through maybe like a browser through which you can access it. I think that is definitely, I think, one of the cool features that Azure provides. Uh, I wish there was like some feature where you can, I don't know, like transfer like a VM to a different VM. So maybe like you have a VM with a particular configuration, and then you want to create a VM with a different configuration, and you want to transfer everything from the first VM to the second VM. I don't think that feature exists, but I think that is, I think, one of the features that might be interesting to have, especially with the kind of requirements that we have.
Cool. Well, that would be a good question that we can save for when we have our Azure vendor presentation later today.
Yeah, definitely.
And so I think we have time for one or two more questions. We have one question. Given the subject matter, how are notions of privacy and compliance handled when using this platform?
Yeah, I think that's a great question. I think so I think regarding privacy, so whenever you create like a virtual machine, it will be hosted in a particular region. So I don't know, like uh, maybe you will be creating your virtual machine in like a Southwest US region, or it might be in a different part of the world. So I think like some of the privacy and compliancy like related rules and regulations are often dependent on that. I mean, I think Azure does say that, I mean, they do take care of privacy, and they do ensure that all the data that you have is like very secured, and like that's not something that you need to worry about. But yeah, I think that's definitely an important concern.
Great. And I guess if you just have we have 1 minute left, but I just want to get this question in because it's a really good one.
Yeah, sure.
Have you looked at training the peer supporter on how to integrate partner suggestions?
Okay, so if I understand the question correctly, it's about it's about like training these users and making them more empathic, rather than like training your models and using your models to like give out these suggestions. So I think I think like in the randomized control trial that we are doing, I think one of the things and one of the nuances that I missed out was basically, I mean, to both the control group and the treatment groups that we are giving them like some sort of training on like what empathy is and what empathic response is and how one can write an empathic response. So we do give them like that basic training, and that is given to like both the groups, and I think that acts as like some sort of like benchmark on like how the users will perform if they were given that basic training. I think there are ways in which you can use the same system, as in like for instance like this particular system that we built, you can use probably the same system for even training these peer supporters. So that way, I mean, you may not be using the system when you actually like give feedback to users, but then you will use them just for giving them training, and then the peer supporters will be on their own. So yeah, I think there are interesting opportunities there. But then like just to like point out to like other related work. So I mean, like people have shown in the past that like just giving people maybe, I don't know, like a 1 hour training or a 1 week training often doesn't suffice, and you like repeatedly need to like give out these instructions, especially to people who are not an expert in like mental health support and not an expert in providing counseling. So I think that is I think another part to it.
That's a really interesting point. And I think it's a cool demonstration of how these tools can, help continue doing this work beyond just this initial push to spark empathy. Um, well, thank you for your presentation, Ashish. So
Yeah, and thank you for all the questions. I enjoyed all of them.
yeah. All right. So I think we can stop recording this session now.